we saw that as we are implementing our new, better and improved. Well, how could it be better and improved? Okay, so we're looking at this other implementation, the compact duration, which is using this single field, but we're running into some concerns, right? That some code is somewhat redundant, right? That it's implemented in both the duration impl, and now again we're re-implementing a lot of that looks very, very similar in this compact version. So let's look at how we could perhaps deal with this redundancy, or how is it that we can extract somehow and factor out some of that code and put it in one single place. For that, we're going to be using this technique called the abstract base classes, right? Having identified some small examples of redundancy, it says, "Ooh, wait a minute! It looks like we are accruing some redundancy as we go." And this is a very simple class, right? And this is a trivial class. Imagine if this were a fairly complex class, right? Where you have one large implementation of one fairly sophisticated class, and now you're implementing a brand new equivalent class with the same interface, but right, you see that there's a lot of redundancy. So it's not an uncommon problem to face, right? Obviously, we're using a very trivial example, enough to point out these challenges. Yes, but obviously it would be a much bigger effort when you're looking at fairly sophisticated classes, and you would still obviously want to apply the same principles. So we anticipate that there will be repetition, right? We are inheriting from the same interface. We are implementing the same signatures, and so we anticipate. So what do? There's definitely going to be more redundancy, right? And we definitely want to look at some techniques where we can factor out things that are common and put it in one single place of maintenance, right? We want to factor it out and identify what those are. Now, typically this happens. This happens everywhere. Redundancy happens everywhere, right? It's like a weed, right? That you have to go in and then pull out. Redundancy just multiplies, right? You just have to go in it's like the second law of thermodynamics, right? Entropy, everything tends to chaos. So we have to go in and put an effort to organize things, right? So certainly you can have redundancy between functions, right? You have one function here, maybe within the same class. You might have a function here that does something, and some other function down there that does something similar, or even the same identical code. If we see that, right, flag should raise and says, "Ooh, wait a minute! Could I grab those two things that do the same thing, and perhaps I can factor out into a helper function, right?" That does that one specific common thing, and then I can call it from two different places, right? Now what I've done is that I've centralized that feature into one single function, and I only have to maintain that one function as opposed to having to maintain two different pieces of code in the same class. Well, what about if there's redundancy across classes, right? We know what to do if there's redundancy within the same class across multiple functions, right? We create a helper function, right? And we can encapsulate that. Same thing with classes, right? If you have redundancy across classes, right, the way to factor it out is to have a helper class, right, where we can factor out the commonalities between the two classes. We can factor it into one single class, and then we can perhaps inherit from it, or declare it as static, or somehow reuse this functionality in one single place of maintenance, right? So yeah, that's exactly what we're going to do. We're going to we see that these two classes, these two implementations are being redundant in some implementation. We're going to factor those implementations into a helper class from where both classes are going to inherit these two features. We're going to reuse that, right? In this case, we have the mechanism, right? Object-oriented technology gives us the mechanism to be able to extend somebody else's implementation and reuse elsewhere, right? So let's take a look at what that might look like, right? We're going to implement inheritance. If you just as a reminder, right? Inheritance is that you have some base class, right, or some base data structure or set of behaviors, And then you can create a hierarchy of inheritance, right, where subclasses or derived classes can inherit those behaviors from their parents, right, just like children inherit from their parents. But then obviously children are free to override or overload, whatever their parents do. My children do. Right, and now there's also in inheritance there's a nuance where the parent class could be a concrete class, meaning it declares all its fields, and also it declares all its functions, its methods, and fully implements those methods. Yes, and then the children can then inherit all those behaviors, all those implementations. They don't have to. They're not obliged to override them. They can inherit all those behaviors from their parent. What we're looking for here is we're going to be using instead an abstract-based class, right? An abstract-based class is a class that is free to just like a concrete class. It will implement most of its methods, but it's free to leave some of those methods undefined, right? Unimplemented, right? And instead, leaving it up to the child to decide the actual implementation, meaning that it's defining a very generic interface at the top of the base class, right? But the actual implementation makes no sense to implement it at that high level, right? Like you might implement the draw a method in a shape class, right? But since not until you know exactly what type of shape it is, will you know how to actually draw it, right? So instead you leave it for classes downstream, children, to actually implement the drawing of 4 lines or a circle or 3 lines for a triangle, right? So it's leaving some of these methods undefined, unimplemented for subclasses, the delegated subclasses to implement. And that's exactly what we're going to do, right? What we're going to do is that we're going to create a class between the base interface, right, and the 2 implementation classes that we have. And what we're gonna try and do is factor out those methods that we see that are redundant, that look very similar to each other, right? And we're gonna grab those and move them into a common class, right? We're gonna move some of these over, right? Some of them will be easy, will be trivial, right? Some of them will not, right? Some of them will be a little more challenging, right? And so very, very much like you would factor out common behavior into helper functions, here we're moving it to a helper class, right? And then inheriting it from the children. Yes?
Would it be safe to say that, like, when you make an abstract class like that, you're just kind of, you're basically just extending upon that interface instead of extending that all the way down to the actual classes? Like, you're making bigger decisions up top, kind of?
Yeah, exactly. So abstract classes is kind of the mixture of a class and an interface, right? Where you want to provide some base implementation that applies to all my children, right? That I have enough level of decisions, right? At this level of abstraction to give a particular implementation, but not everything. A couple of things I don't have enough information to implement them, and instead I delegate it to my children to make those kinds of decisions, right? So yeah, it's a mixture of both an interface and notice that it sits nicely between these two, right? The interface is very, very high level, right? It provides no implementation whatsoever, right? The abstract class is a little more concrete, right? But it's implementing only some of them, right? But leaving some of them undefined for the posterity, for the next generation to look at that. Yes?
By leaving that empty, the abstract duration class, what is the purpose of having it?
Oh, right now, nothing. Yeah, right now it's a placeholder, right? And we're gonna start moving stuff into that abstract class. Right now it's not playing any role. So we'll move a couple of these that are trivial, right? They're very easy to move. Some of them are going to be a little more challenging, and we'll see how to deal with those, right? Yeah, and as we move them, we'll see that there's some of them have some twists and turns, are going to introduce a couple of other concerns and we'll see how to deal with them. Okay. All right. So here are a few implementations. This is how you would actually implement it. Here's the class diagram. And so this class diagram, the way to implement it, right, is that we're going to have to go in and tweak a little bit our implementation classes. Instead of having the duration impl implement the interface, instead it's going to extend the abstract duration, right? Instead of the compact duration implementing the duration interface, instead it's going to extend the abstract duration, right? So it's going to sit right in the middle. And the abstract duration, instead of these two implementing the duration, right, we're going to have the abstract duration implement the duration interface. Yes? So it's going to sit right in the middle of the two. So formally, this is what you would, the way you would write it, right? You would have the abstract duration that sits in the middle, implementing the duration interface, and then the two classes that I wrote the same. These are supposed to be. This is supposed to be duration impl. There we go. Right, it's going to. Both of them are going to. What's going on? Okay, there we go. Yeah, they're both going to be extending the abstract duration. Yes. Excellent. Is it still recording? Yeah. All right, so let's move a couple of the methods, right, that are trivial. These are very simple. Since all these methods that they're all written in terms of the smallest unit of seconds, right? Remember that we wrote a lot of these functions. We wrote them in terms of seconds. Since they're already written in terms of seconds, they don't do any transformations. They don't do any of that. We can just move them up, right, and just put them in the abstract duration just fine, right? There's nothing for us to do, right? Some of the other ones are not. The other ones do have some dependencies on the internal workings of that particular implementation, and we're going to have to think about those a little more, right? Some of them do depend on knowing hours, minutes, and seconds, so those we can't just move them around, right? Instead, the other ones, that since they only rely on just the underlined seconds, right? We can just move it just very, very easily, right? So those are easy, no problem. We can move them, and right there, we're golden, right? We no longer have the redundancy of having these two identical pieces of code, right? And we can put it in one place, and we're inheriting it, right? So we've made a great decision here where we only have one place to maintain this. If we ever need to change the toString or the equals or the hash code, if we ever have to maintain this, right, there's only one place that we have to maintain it, right? Not across two different places. Yes?
Isn't hash code not quite the same between them? I think it didn't on the duration impl we added we passed like objects.hash the 3 field.
We did. That was the first implementation, right? And then we said that a better implementation was to bring it down to the seconds.
Oh, and then okay.
Yeah, we said, is there a better implementation? And then we went down to seconds, and we had to change both, right? The equals and also the right, because also the problem with equals using hours, minutes, and seconds is that you had to do some arithmetics, right? So that 1 hour 30 seconds was supposed to be the same as 90 seconds, right? So he says, oh well, maybe it wasn't a good idea, right? So we brought it down to seconds. Yep. So yeah, that's the one we're moving over, right? All the 4 methods that we know are written in terms of the lowest common denominator, just seconds. The other 3 are not quite as trivial, and we're going to have to revisit them one by one. So let's take a look at them.